problems on your assignment. So my suggestion is paying attention and listening so we can move sort of quickly. 57, they give us a chart there. Last year in algebra, you might have made your charts, depends on the teacher, different teachers teach it different ways. You might have made your charts up and down like this instead of sideways. Still means the same thing. Here they give us the x's that we want to find or plug in. -2, -1, 0, 1, 2.
Isn't it 7, 8, 9?
I'm not sure yet because I haven't done it. So this is what you get once you plug in. They actually put y equals, they put the whole equation in there. That probably confused some of you. Now a lot of you like to change everything to a decimal. It's probably easier on this one to change it, just leave it as a fraction. Because what's -2 minus 3/4? Be careful. Well, as a matter of fact, let's go down here. Let's start at the bottom. What's 2 minus 3/4? 1 and 1/4, right? What's 1 minus 3/4? 1/4. What's 0 minus 3/4? -3/4. What's -1 minus 3/4? Be careful. Think about your pattern. -1 and 3/4. Good. What's -2 minus 3/4? If you put those in decimal form, I wouldn't mind so much, but it was probably easier putting them in fraction form than in decimal form. Next question. Go ahead, is 23. 23. All right, this is one of them that we didn't really get a chance to completely go over last time. If you have graph paper, it might have been best, or it might be best, and we're going to talk about these a little more today, might be best to draw it on graph paper so you can actually see it. All right? Mine's not going to look too good because I didn't put a piece of graph on here. Let's see, for 23, they got the point, wow. They got the point 15, -21. This one's probably one that you don't really want to graph. And 5x plus 2y equals 4. First thing we're going to do, we're going to graph this point, 15, -21. What's 15, -21 tell me to do? How much does it, how's this tell me to move?
Go over.
Which way?
Right.
Go to the right. Please always tell me right or left. If you just say go over, do I know which direction you're telling me to move? So right or left, this is right, 15, and
Down 20.
down 21. Right 15, down 21. Who knows? Somewhere down in there. Probably wouldn't want to graph this one because it's too big. Now we got this. What we want to do here, there's 3 steps. We want to write an equation. This line is going to run somewhere. We want to write an equation of a line that goes from this point to this line that's perpendicular, because the perpendicular is always the shortest path. All right, so we got to write that. The bad thing here is this is in the wrong form. It'd be better if it was in that slope-intercept form. From algebra last year, anybody remember how to start to get this into slope-intercept form? Minus 5x, good. Minus 5x on both sides. These cancel out. You got 2y. Now, Harry said subtract 2y on both sides. Could you have done it that way? Yeah, it doesn't matter. Here we can't put these together because they're not like terms, so we got minus 5x plus 4. Now what? Divide everything by 2. And I'm going to divide each one of those by 2 separately. Leaves us with y equals, can't really divide 5 by 2. It's not going to come out even, so I'm just going to leave it this way. -5 over 2x. What's 4 divided by 2? What's the y-intercept in that equation? 2 is your y-intercept. Stuff you gotta remember from algebra last year. What's your slope? -5/2. Alright? So you remember all this from algebra last year. To graph that, where do we start at on the graph? Start at 2. So we go up 2, put a dot, somewhere about in there. What's this slope tell us to do? Down 5 to the right 2. Down 5, we went up 2 here, so down 5 is going to be somewhere about in there. Right 2, down 5, right 2, so on and so on. Our line's going to look something like that. Now we want to find the distance from here to here. Again, when we find that distance, do I want to draw it so it comes like up here somewhere?
No.
We want it to go directly over here and form a right angle. So what we need to do is we got to find the equation of this line. The way we're going to find the equation of that line, and we're going to do a couple more of these here in a couple minutes. The way we're going to find the equation of that line is we need to find the m, the slope of that line, and the b. So we want to find the slope and the y-intercept. Slope's not too difficult because we want it to be perpendicular to this line that we just drew. What was the slope of that line?
Y.
-5/2, right? If lines are perpendicular, what do you know about their slopes? Opposite reciprocals. So if this new line that we're making is perpendicular to this one, then the slopes should be opposite reciprocals. What's the reciprocal of 5/2? 2/5. What's the opposite of a negative? Positive. So that's the slope of our new line. 2/5. Alright? Now we got to find the b. The way we find the b, we use y = mx plus b. We want it to go through the point. We know the point. We want it to go through that point and have a slope of that. So all we're going to do is in place of y, we're going to stick in the y coordinate right here. In place of x, we're going to stick in the x coordinate. In place of m, we're going to stick in that number. Somebody have their calculator out so they can help me here in a minute. Because we're going to change all this into decimals so we don't have to mess with it. Slope is 2/5. X is 15 plus b. All that's left there to find is the b. That's all we have to find is the b. We really don't need a calculator on this if you know how to deal with fractions. You just multiply the whole number times the top. What's 15 times 2?
30.
30, and then divide by 5. What's that give you?
6.
So we really didn't need the calculator this time. It came out sort of nice and even. What do we do with that 6 to get b by itself? What's b equal? -27. Again, probably not something we'd want to graph, right? So we got this. We got all this information about this new line that we drew right here. What equation can we write? Y = what? 2/5 x minus 27. That's the equation of the new line. Now Harry's looking at it and he's going, but they didn't ask us for the equation of the new line. That's true, they didn't. But we're going to use this and this right here to help us find the distance there. Because what we need, we want to find the distance from here to that point right there. Well, we need the coordinates of that point. We know the coordinates of this point. It's 15, -21. But to be able to use the distance formula, we need the coordinates of this other point. Now we're going to take these two. Somebody have these two equations written down for me? Because I'm getting ready to erase my slide. Yes, no, maybe? Somebody got both of them? All right, now tell me the two equations. Y = what? Plus what? 2. And what was the other one? 2/5 x minus 27. Now what we're going to do here, and a lot of you said last year you didn't like substitution, but that's what we're going to use. We're going to use substitution because we have y by itself here, y by itself there. I know that y equals that. If it didn't sharpen, you can use that one right there. You're not going to bother. So if y equals that, I can take that and stick what in place of y right here? That whole thing. So I'm just going to stick that in there. Now we're going to need our calculators because I'm not going to do all this out without doing decimals. What's nice about that new equation? It's only got what in it?
X.
X's. It's only got X's in it. First thing we're going to do is we're going to get all the X's on one side. Well, before we do that, what's this as a decimal?
2.5.
Negative 2.5x. If you get a problem like this, I don't have any problem with you. What's that as a decimal?
0.4x.
Changing some of this into decimal form, make it so you can use your calculator. So I want to get these two together, so I'm going to add 2.5x on both sides. Those cancel. You're left with 2 over here. What's 2.5x and 0.4x give you? 2.9x minus 27. Add 27 on both sides. What's 2 and 27 give us?
29.
Equals 2.9x. Divide both sides by 2.9.
X equals 1.
Be careful.
10.
X equals 10. Now remember, and I erased my graph over here, but what we were looking for, we had this line that went down through here, and we had some point right here. We're looking for the coordinates of that point right there. That's what we're trying to find. Well, we just found half of it. What's the x coordinate right there? 10. So the x coordinate's 10. Now what else do we still need to find? The y. We plug in whichever one of these we want. I'm going to plug into this one. 2/5 times 10 minus 27. 10 times 2 is what? 20 divided by 5. 4 minus 27 is what? Negative 23. So what's the y coordinate? That's the second step. We sort of got to this a little bit last time. You wrote down the steps, but we didn't get to all of it. Somebody write down this point for me. And what was the other point? What was the original point up here?
15.
Do we have 2 points? Can we use the distance formula now?
Yeah.
So I'm going to erase all this. This is the third step in the process. What were the 2 points?
10 negative 23.
10 negative 23 and negative 21. We're trying to find the distance between those 2 points. That's what we're finding. That's going to tell us the distance from the point to that line, because that's where it made a perpendicular. So we're going to use the distance formula. What's our x coordinates? 10 minus 15 squared. What's our y coordinates? Negative 23 minus a negative 21 squared. What's going to happen there? What is 10 minus 15? Let's do some of this in our heads. What's 10 minus 15? Negative 5 squared. Positive 25. Negative 23 plus 21. Negative 2 squared. 4. 25 plus 4. 29 a perfect square number? Somebody grab her calculator. What's the square root of 29?
5.38, 5.648,
5 point what?
385.
So we'll say 5.4. So when we drew that graph, and we had the line, we graphed the line, then we had that point they gave us, how far is it from that point to that line? What's the length of that segment right there? About 5.4. All right, so that's the shortest path from that point to that line. Does that mean that that path is going to be 5.4? No, just the shortest one. All right, what I want you to do, on that paper, the one that you grabbed as you were coming in, that's going to go in your notes for today. We're going to go through, and I'm going to show you how to do these. It's this exact problem. Hopefully this one here won't be quite as difficult as that one was. That had big numbers in it. Made it a little harder, right? So this one should be a little easier. So go ahead, you can put that in your binders. We're going to write on it. You're going to fill in how to do each thing. So first thing, in the first step, I know you might not have a whole lot of room, especially if you write big, to put it on this paper, so figure it out, all right? Try to figure out best way you can. Whenever you're finding the distance from a point to a line, you're finding the distance from a point to a line. So we got this point and we got this line. First thing we're going to do is we're going to graph them. So right there on your graph, let's start off, graph the point 1, 0.
You go over right one.
Go right one, put a dot, right? So graph it on your line, or on your graph. Now you don't have to graph them. I'm going to graph them.
She wanted a pen. I wouldn't want it. She's 3 at me. I need to love you.
We graph that, then we're going to graph the line. How do we graph a line again? Do we really want to make a little table and everything? It's unnecessary, isn't it? To graph this line, what do you look at?
The 3.
The y-intercept, the 3. So what's that tell you? Where's that tell you put a point? Go down 3 and put a point. So you go, or I'm sorry, up 3, not down 3. You go up 3 and put a point. That's our y-intercept for our line. What's the slope of this line? -1. If it helps you, put a 1 underneath that to make it a fraction, because it's rise over run. So what's that tell me to do?
Down 1 to the right.
Down 1 to the right one, down 1 to the right one, down 1 to the right one. You graph all those points. You graph all those points, down 1 to the right one, down 1 to the right one, down 1 to the right one. Then after you graph 4 or 5 of them, what can you make? You can make your line. Now the whole thing, what we're trying to do here is we're trying to find the distance from this point to this line. Do we want the distance to come down here somewhere? No, it's got to go over here, and what's it got to form?
Right.
A right angle right there. So we know this new segment that we just drew in here has to be perpendicular to the original line. It's got to be perpendicular to the original line. That right there is the distance that we're looking for. We're looking for that length. Again, you don't have to graph all these if you don't want to, but if you're more of a visual person where you need to see it and say, okay, I'm looking for that length right there, then it might be helpful. That's up to you. These 3 steps that I have on your paper, the first one's only up here. These are the 3 steps we need to do to find that length. First thing we're going to do is write an equation for a line. If we're going to write an equation for this line right here that's perpendicular, or that segment that's perpendicular, we need to find 2 things. We need to find the slope and the y-intercept of it. What'd you tell me the slope of the original line was? -1 over 1. If this is perpendicular, it's got to be the opposite reciprocal. So what's the slope of that going to be?
1, -1.
Be careful.
1 over -1.
Just 1 over 1. Opposite reciprocal, you flip it over, change the sign. All right? Don't change both signs. Just change one of them. If that negative's on top, does it really matter if it's on top or on bottom? No, it's just telling you that whole number right there is negative. So when we change it, we want our number to be a positive. All right? Now we got to find the y-intercept, and we're going to do that by plugging into that y equals mx plus b form. We're going to use this point, and we're going to use that slope that we just found. And you're going to plug in here, plug in here, plug in here. All it's going to leave is b. What do I plug in for y this time? 0, good. What do I plug in for, that came from right there, that's your y, that's your x. What do I plug in for m? 1. Plug in for x, 1 plus b, and you do a little math. Can you probably do most of this in your head? What's 1 times 1? 1. Then we're going to do what with that 1? Subtract it on the other side, so what's it come out to be? So b equals -1. Tell me my equation now. If I know the slope and the y-intercept, what's the equation of that little segment? 1x minus 1. That's our new equation. That's the first thing we do. Write that equation. We wrote an equation for that. Now it's actually the equation for the line, but we don't want that whole line. We just want the part from that point to there. But that's still the same equation. I'm going to write that down over here. So, because mine I think is going to change slides. You guys should have it written down right there. So that's part 1. That's all underneath number 1 right there. So Jason, you fit it all underneath there pretty easy. I gave you enough room, didn't I? Here, I thought I was not giving you enough room. Next thing we do, second step. Forgot. And all that worked out right there. I wrote it out instead. Second step, find the point where the 2 lines intersect. Oh, I forgot to write down, what was the original line? Y equals what?
-x plus 3.
So I'm even going to put this in, -1x plus 3. Still the same thing, right? Just I put in the 1. So we got these 2 lines. Y equals -1x plus 3, and the line that we just drew, y equals 1x minus 1. All you're going to do with that, you got those 2 lines, you're going to take this, set them equal to each other. That's going to tell you where that line that we drew in, where it touches the other line. So we're going to take those 2 and set them equal. -1x plus 3 equals 1x minus 1. How do I start to solve that? Add 1x on both sides. What's that give us? These cancel out, right? 3 equals 2x minus 1. Now what? Add 1 to both sides. Tell me what that leaves me with. Now what? What's x equal? Remember, what we're looking for, even though I don't have my graph up here anymore, gotta remember what it looked like. Let's see one of your papers. So our line went something like this, and we had a point right here, right? Is that about right? We're looking for where those two, where if we drew a line from that point where it's going to intersect that. Well, the x-coordinate is going to be what? 2. What do we still have to find? The y-coordinate. All we're going to do is take this 2 and we can come back up here anywhere and plug it back in. I'm going to plug it in right here because that looks pretty easy. So y equals 1 in place of x. What am I going to stick in there? I figured out x was 2, so I'm going to stick 2 right in there. What's 1 times 2? 2 minus 1. So what's the y part of the ordered pair? What was the other point that we started with? 1, 0. So we got these 2 points. We're trying to find the distance from here to there. What are we going to use once we know those 2 points? Distance formula. Oops. We come up, yep, 2, 1. Just make sure that I'm not doing anything wrong. What were our 2 points? 2, 1 and 1, 2. Doesn't matter which order they're in. Is that what you guys told me? Or 1, 0, right? So 2, 1 and 1, 0, is that right? This is the third step. We know those 2 points now. We're on our graph. You got your line coming down through here. You got this point right here. You're looking for that distance from here to there. We know this point is 1, 0. Oops, 0. That's 0, 1. You guys, is it 0, 1 or 1, 0?
No, that's 1, 0.
So it's right here. Not that. 1, 0. Trying to find that distance, and we know this point is 2, 1. Now can we just count and go, okay, from 1, 0 to 2, 1, that goes up about 1. Will that work? No, because it's diagonal. If it was horizontal or vertical, then we could just count maybe.
If it was really that easy, I'd did all that work.
And that's why maybe we graph them first to make sure. Because if you graph this and your line looks like this, your line looks like that and your point's right here, and we're trying to find that distance, do you really want to go through all this work? Because then you could just count the spaces. So that's why we graph it first, just to get a look at it. So on this, we got to use the distance formula. What's our x's this time? 2 and 1. What's our y's? It's 2 minus 1. 1 squared. 1 minus 0. 1 squared. 1 plus 1. 2 a perfect square number? Somebody do it on their calculator for us. What's 1.4? So how far is it from this point to that line? About 1.4. Remember, that's got to be the shortest path. It's got to be the perpendicular. So 3 things you do. You write the equation for the new thing first. For the perpendicular, you write the equation. Then you find the new point, the point where the 2 intersect. Then you use the distance formula with the original point and the new point. So that helped? Gosh, that makes me feel good. I'm such a great teacher. I'll probably retire. I'll probably walk downstairs here in a little while and tell them that I'm retiring because my life is fulfilled now because I taught you. My hillbilly upbringing was coming out there when I said that one. I asked somebody yesterday which house they lived in.
The one that I live in.
And I asked them for a reason, and they're all like, "What's wrong with him? Why is he asking me what house you live in?" And I was asking him what house because I grew up on the street hooked to, adjacent to his street, and I just wondered which house he lived in, because I know the house. I didn't bother, because they're going, God, he's some kind of weirdo or something. Why is he asking him what house he lives in? On this next one, look at the second page. We'll go through this one a little bit quicker. Time to say this class is over?
You said 12:15.
We got 30 minutes. We got a little time. I was thinking 11:44. That's the other class, isn't it?
That's the end of that lunch break.
First thing we're going to do, write an equation to the line perpendicular.
Wait, didn't we just do this?
No, we just did this one. Sorry. I forgot that I put this on there. Unless I messed up and you know what I should probably do. Discard into show and figure out which slide I want to be on. Nope. 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 Yep. Haha. Finally. So we're trying to find the distance between those two lines. We're going to graph these two lines. These lines, I look at them right away and I see that the slope of this one, what's the slope of this first one? 2. What's the slope of that one? So what's that tell you about them? They got to be parallel to each other. So we're trying to find the distance between these two parallel lines. I'm going to graph this one. I'm going to do it real quick. We start at 1, so go up to 1, put a dot. It's going to switch on me. Previous. Pointer options, pin. Put a dot right there. Slope is 2 over 1. Tells me to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. What if I run out of space going that way? Down 2 and to the left 1. Down 2 to the left 1. Down 2 to the left 1. That's our first line. Next one. Y-intercept -3. Down 3, put a dot. Up 2 over 1, or up 2 to the right 1, 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 up 2 to the right 1. Our second line looks something like that. Two lines should be parallel, which it looks like they are. We want to find the distance between those two. Now when we go to find the distance between those two, here it is way out in front of me. Quit jumping ahead of me, make me feel stupid. Now, you got to be careful, because can I just count that right there and see it? And say it's 2 blocks? Is that perpendicular to those two lines? So it's not the shortest path. Right? Now when you look at it, that's what a lot of people are going to think. If we're on a test and maybe you don't quite remember how to do this, put that down. If they were both vertical or both horizontal, then you could just count, right? But with them slanted like this, it doesn't work. So we need to be perpendicular. We need this to go over there perpendicular somewhere through here. First thing you're going to do, you pick a point on one of the lines. Doesn't matter what point you pick some point.
0, 1.
I'm going to pick that point right there that Dawson picked. Why would you pick that one, Dawson?
It's closer to the line of origin.
I would pick it because it's got a 0 in it and it's got a 1 in it, and that's easy to do the math. So 0, 1. So I picked this point right here. That's the point I'm picking. Now what we want is we want the line that goes from there to the other line, but we want it to make a right angle. So it's going to look something like that. And maybe I should make that in a different color. So we're looking for that length right there. That's what we're looking for. Should have made these two lines farther apart so you could see it better. So we're looking for that length. Well, what we got to find is we got to find the coordinates of that point. So all we're going to do basically the same thing we just did on the other part. We're going to write an equation for this black segment. We're going to figure out where the two cross at, and then we're going to use the distance formula with the 2 points. We already know this point, 0, 1. Dawson just told us that. That's the one we picked. It doesn't matter what it is. So the first thing we're going to do is write an equation. Let's try to go through this pretty quickly. If the slope of this one's 2, what's the slope of the new one going to be? Flip it over, take the opposite. -1/2. Then we got to find the y-intercept, which is b. The way we're going to do that, we're going to use y equals mx plus b. That point that Dawson picked, we're going to use it. So what goes in place of y? 1. What goes in place of m? Nobody wants to say it because it's a fraction. What goes in place of x? 0 plus b. Now look at what happens. This is nice. What's 1/2 times 0? So what's b end up equaling? What's our equation of that black line? -1/2 x plus 1. I'm not switching, I'm just changing my pen color. I can't see the black in here, so I need to change it back. We use this line right here. So what we're going to do next is use this line. We're going to take this new line that we got and this line, and we need to know the coordinates right there where they intersect at. So all we do is we take this part and we set it equal to that part. So we got -1/2 x plus 1 equals 2x minus 3. If you want to get out your calculator to make this easier, go right ahead. Because what can we change that -1/2 to? -0.5. So let's change that to -0.5. So we got -0.5x there. What are you going to do first? Add 0.5x to both sides. Oops, 0.5x. That's a point there, not a 2. These cancel out. That leaves you with 1 equals, what's 2 plus 0.5x? 2.5x minus 3. Now what? Add 3 to both sides. Good. I'm going to rewrite this up here. Put it down too low. What's 1 plus 3? 4 equals 2.5x. Now what do you do? Divide both sides by 2.5. What's x equal? 1.6. What's 1.6? That's the x coordinate where these two cross. 1.6. What else do we still have to find? The y coordinates. So now I take that 1.6. I'm going to go back to, I don't know if I'm going to use that one or this one. Yeah, probably that one because this one's got a fraction. So y equals 2 times, what did you say x was? 1.6 minus 3. What is 2 times 1.6? Grab your calculator. 3.2. What's 3.2 minus 3? 0.2. That means the y coordinate is 0.2. Once we have those 2 points, do we care at all about these 2 parallel lines? All we care about is the length of that segment right there. And all we need are those 2 points to find that. I'll give you a second, make sure you got it written down. I wish I would have. Sorry I wrote this so sloppily. Jenna, can you follow it? Are you lying to me just because you're a nice young lady and you don't want to be mean? Sure?
I can't.
See, Ginger's not nice young lady. She wants to be too.
Being honest. I mean,
I'm just kidding with you, Ginger. So where did I lose you at?
no, way back when you're trying to find that
low. And I jumped up to here.
Oh. Oh, so that thing on the bottom doesn't even work?
This is me doing the work, and then I jumped up to here because I couldn't bend down any lower.
Oh.
Sorry. So this is finding the x. It's just backwards. Started here, went down this way, then I jumped up here and went that way. Then I found the y over here. Find y. What's the last thing we got left to do? We're going to use those 2 points that we found. Does everybody sort of have that? I'm getting ready to erase them. Close, Harry. You sure? Don't let me rush it. You got it?
No.
So we're going to use these 2 points, 0, 1. I just erased my graph. Got to quit doing that. And 1.6, 0.2. We're going to use the distance formula. I would highly suggest you just take your calculator. If your calculator prints across the screen, you could try to punch all this in all as one thing. And then you don't have to worry about it. Harry, can I borrow your calculator? It was real nice of me to pick it up first, then ask, wasn't it? Yep. I apologize, Harry. Usually I don't do stuff like that. We subtract these two. 1.6 minus 0, that's our x's. 0.2 minus 1, square that. If we punch all that into your calculator, some of your calculators will put parentheses in for you. Some of them you might have to put in. You got to be careful with that. So I'm going to punch it all in. And if you get the same answer I got, then you're probably all right on your calculator of how to do it. Hit second square root. That's wrong on mine. I hit the wrong thing. Second square root. See, Harry's puts in a parenthesis already. So that means I got to put another parenthesis in there to start with. I do 1.6 minus 0, close the parenthesis, squared, hit the squared button, plus another parenthesis, 0.2 minus 1, close the parenthesis, squared button. And then I got to remember at the very end to close the parenthesis that the calculator put in. So Harry's going to push equals, give us his answer.
1.7888.
So we'll say about 1.8. Yep. Anybody else get 1.8?
No, I got 2.24.
2.24.
You have to add in whatever.
So let's look back. So we hit second square root. See how they already put a parenthesis in there for you?
But you have to put another.
You got to put another one.
Oh.
And then at the end, you got to remember to close that one after the last square.
It was very confusing. I got that. I did.
Some of the calculators put a parenthesis in there, some of them don't. The older calculators, like mine, don't put the parentheses in there for you. But then last year I got a new one, and it sticks it in there. So, I don't know.
It shows its age. 1.9.
1.8? Anybody else having trouble with their calculator?
Oh.
Molly, did you get that? Did you get something different? You were looking confused like you...
The only thing I don't know how to do with my calculator is put bars and.
The square root? Probably, is there an x squared button?
Yeah.
It's probably, you gotta hit second, then
Okay.
right, looking at this, we got about, what, 20 minutes? Yep. What I wanted to do on this, first of all, we're going to skip over the first page for a minute. Well, I don't know, you want to do the first page real quick?
Yeah.
Since Ginger's complaining that there's 80 problems, and that she looks at the first page, the first 15 of those 80 should take you all about
1 minute.
not very long, right?
So we'll skip over the first page.
Unless you actually go.
So we want to skip the first page?
Yeah. Because the first page is the easiest to do.
So you want to do it by yourself? How about if we do this? Let's do number 16. Because it's not quite as hard, or not quite as easy as the others. What's 16 wanting you to find? Find the distance from A to T. So if we're trying to find the distance from A to T, what are we going to do? Use the distance formula. Before we can use the distance formula, what do we got to find? We got to find what A is, what the coordinates of A is, and what the coordinates of T is. Somebody help me out. What are the coordinates of A?
5.
Say it again. 1, 5. Coordinates of T? 2, 7. Now we're going to use the distance formula. Get your calculator out so you can just plug this all right into your calculator, hopefully. What's our x's?
No, 9.
What's our x's?
1 and 2.
1 and 2. 1 minus 2 squared. What's our y's?
No, actually.
5 minus 7 squared. Somebody plug all that into their calculator just like that and see what you come up with. What is it? 4.1. Anybody else get? What is he got? 4.1?
What's 3.2?
Which calculator? Which calculator? Somebody get something different?
Yeah, I got 2.23.
2.23. So we're between 4.1 and 2.2. 2.2?
I said 80, 90 mil.
Do it on your calculator so you make sure you're doing it right, knucklehead.
I got
I wanted to say something a little worse than that, but I caught myself. 2.2, is that what we're going with? Look up at A to T.
Sure.
Does it look like it should be a little more than 2?
Yeah, because
Yeah. Does it look like it should be 4?
No.
No, 4 looks like way too much between those two, right? So that's our answer, 2.2.
Okay.
Let's look at 20 real quick.
I'm not sure what's wrong with my calculator. It just says the square root of 5.
Because guess what 2.2 is? 2.2 squared is the square root of 5. So if you hit equals again,
Same
just
thing.
says square root of 5. All right, now do this. Then hit second equals. Remind me in intervention. I'll show you how to get to it because some of the calculators are different. I'll show you how to change it to a decimal. All right. So let's look at 20. This is going to be an easy one, isn't it, Jim? So if we look at 20, we want to go from point E. Point E is somewhere like right in here. That's pretty close to where E is. And AC, line AC is over here. That's A. That's C. And close enough. It's not exactly, C should be up a little higher. Right about there, right? Now they said line AC, so it's this line going down through here. When I try to make my distance or find my distance from E to line AC, am I going to go like that?
No.
How do you want to go over there?
Just
Make a right angle.
It's got to make a right angle. It's got to be perpendicular. All right? Well, what's nice about this line again, Ginger? It's vertical. If that line happens to be vertical, that means this line is going to be horizontal from E over to that line. So all we got to do is what? Just count. Somebody figure out.
5.
5. Now don't count mine. Count on yours because mine's not right. 5. That's the distance on
I
that.
feel like yours is right.
Yeah, it was, but that was just like it wasn't on purpose that it was right. On the first page.
That's not a good help.
21.
Find me another one.
21.
21. We just want to fill in the blanks there. It's not something you guys could do on your own. Fill in the blank with the word or phrase to complete each sentence. The distance from a line to a point, not on the line, is the length of the segment blank to the line. Perpendicular. Perpendicular. Now, I see Harry up here writing it all out. What's a smart person going to do? Put that little symbol.
I know my spelling. It's cool.
Part B, two coplanar lines are parallel if they are blank, or they are everywhere blank. This is a word you probably don't know yet, but we're going to use it a whole bunch throughout the year. If I got, what did it say again? Two coplanar lines. So I got these two lines. They're parallel to each other if what's true about that length, that length, that length, that length, that length. They're all the same. They're all the same. Now, don't write same down because that's not the answer. The answer is equidistance. What do you think equidistance means? Equal distances. All the way down through there. Equidistance. Kelsey's back here all worried about her spelling. Don't worry about it. Equidistance. If it looks anything like equidistance, I'll be fine with it, Kelsey. Kelsey, if it looks like this, then I'll probably mark it wrong. But if it looks like equidistance, letter C. In a plane, if two lines are both equidistant, oh look right there, you could have spelled it from the next one. From a third line, then the two lines are blank to each other. Parallel. C. D, the distance between two parallel lines measured along a perpendicular to the two lines is always blank. Equal, the same. Equal, either one. Equal or the same, yeah, they're both the same thing.
I didn't get C.
What was C again? Parallel.
What's D? So I was listening to the song.
Letter E, to measure the distance between two parallel lines. Measure the distance between one of the lines and any line on the, or any point on the blank. Same answer as letter A. Perpendicular.
Any point on the perpendicular.
What is the again?
Huh? C again? What was C again? E. What was E again?
D was equal to.
What do we want to do now? I got to turn the music off, don't I? Because we shouldn't have had to. We answered each one of those questions about 4 times, each one, A, B, C, and D, because people stopping and listening.
It's just a song.
I haven't gotten to hear this song at all this song, but I need to.
I've heard this.
Look at 22 real quick. 22. On there, draw the distance from P to line L. Just draw it on your paper. P to line L. 23. Now, or 22, not 23, 22. Somebody else said 23, and I said 22, and then I got confused. What's Jenna going to make sure? She's got the right line drawn in there, but she wants to make sure that she puts what when she's done drawing that line?
The right angle.
The little box down there where it connects. How about, let's look at C, a little tougher on this one. We're going from point E to line FG. Is that going to work? Is that going to work?
No.
You gotta go straight down. So what do we gotta do to this line right here? Extend it out. Since it's a line that extends out, then you get that. Find that distance. Let's do 25 just because I like it.
Okay.
I'm less than what? You sure? You can understand it, I'm sure.
After this, can we do like something on the very back?
The hard stuff, yeah. 25 says write an equation in slope-intercept form. What two things you got to know to write an equation in slope-intercept form? Slope and the y-intercept, the m and the b, right? So, let's do this real quick. So this is 25. They tell us the slope is 2. The y-intercept, which is b, is -3. Your equation's y equals mx plus b. So tell me how to write this equation.
Y equals 2x.
That's it. Don't make those harder than they are. That's all you got to do.
Is this stuff hard, or are there just like a lot of steps you gotta do?
Some of it's hard. Most of it's not.
So you're lying, okay?
Look over at page. I'll never lie to you, Bill. Look over at number 53. Number 53, I want to do this real quick. We're going to write an equation. This time, these are the ones that nobody ever seems to like. And these are the ones that I think are just as easy as that last one we just did. We want to write an equation for the line that has a slope of 1/2 and goes through the point 3, -1. Do I really want to use that slope-intercept form? No, because it's got a fraction. That's going to make it harder to find b. Makes it a little more work. We don't want to do all that. All right? What's a better form? Point slope. If I use this form, don't make this harder than it is. If I use this form, I'm going to plug in a number right there. I'm going to plug in a number right there. I'm going to plug in a number right there. And that's our answer. What do I plug in place of y sub 1? What's our y coordinate? -1. So if I'm minusing the -1, what happens? +1. What do I put in place of m?
Slope.
1/2, the slope. What do I put in place of x sub 1? 3. That's our equation. Yeah, it's -1, but it was minus a -1. So now, if Harry gets all excited, he's doing those, and he wants to change that into slope-intercept form. Can he go right ahead and do it? Yeah. All it takes to change it in slope-intercept form is 2 steps. You distribute out the slope, so you distribute, and then this number that's over here with the 1, you move it to the other side. So you move the number. It's not hard to change it into slope-intercept form once it's in point slope. Right now, Elijah, you can pick me one.
Alright. Let's do 80.
Find the distance between the 2 parallel lines. So this is like what we were doing a minute ago, right? When we were doing notes. I'm going to try to graph them real quick. How do I graph the first line? Y equals x plus 9. Where do I go? Up 9, put a dot. What's the slope of that one? So I go up 1 over 1. The bad thing with that is I'm going to be off my graph probably, right? So how else could I get them? Down one to the left one, down one, left one, down one, left one. So our line's gonna look something like that. How about the next one? Where do I start it at?
You go up 3.
Up 3, put a dot somewhere about in there maybe. Up 1 to the right one, up 1 to the right one, up 1 to the right one, up 1 to the right one. Or I could go down 1 to the left one, so on, so on. Line's gonna look something like that. Again, do we really have to graph? I put graphs on here on a lot of them for you. Do you really have to graph any of them? That's up to you. If you like to see it so you can get a picture of it, it might be helpful. Otherwise, it's not a necessity that you have to graph. So I'm trying to find the distance from here to here. Sometimes, like maybe this one might work out this way. If I connect those 2 points right there, if it happens to hit both those 2 points, does that look like it's a right angle? Yeah, would it be better if I was on a actual graph so I could tell for sure? Yeah, with my picture you probably don't want to do that. So we want to pick a point on one of these 2 lines. I'm going to pick this one right here, just because it's easy. What is the coordinates of that point right there? What was the y-intercept of the second line? I did that on one of the other problems, didn't I? 0, 3. Now we got to find this point. The way we find that point is first write an equation of this line. What do we know about this line? It comes up here and it forms a what? Right angle. If our original line, y equals x plus 9, y equals x plus 3, what's the slope of both those lines? 1. So what's the slope of this line? -1. Opposite reciprocal. And if it's just 1, it's just -1. Now we got to find b. Well, we know it goes through that point, and we know it has a slope of -1, so I'm going to do this. 3, plug in for x. -1 is our m. 0 is our, I'm sorry, that was y. This is our x. Plus b. What's -1 times 0? 0. So what's b equal? 3. What's the equation of this line? Y equals what? -1x plus 3.
You'd have to do that for 79 and 78.
Yep. Now once we have this new equation, we're going to take this part. We're trying to find this point right here. So what we're going to do is we take that part and this part from that other line, and we set them equal to each other. So x plus 9 equals -1x plus 3. Now I know these two look sort of alike. Don't get them confused though. It doesn't have anything to do with the other. What do I do to solve this?
Add an x.
Add x. What's happening with it? 2x
Plus 9.
equals 3. Now what?
Minus 9.
What's 2x equal?
2x equals -12.
Careful. -6. Divide by 2. What's x equal? -3. So what's the x coordinate on this point right here?
3.
-3. How do we find the y?
13.
Plug it in. I'm going to plug it in right here. What's -3 plus 3? 0. So what's y equal? Hold on now. Oh, I plugged it in the wrong one, didn't I? Plug it in there. -3 plus 9, what's that? Somebody said that and I wasn't listening. So that point is 6, not 0. We just found the same thing over again.
And that's the answer.
Only back.
It's -36.
Now is -36 our answer? What are we still trying to find? We found those 2 points so that we could find the distance. Right? So that we could find the distance, use the distance formula. Did it hit an exact point there like we thought maybe it would? Yeah. So if you get lucky and you're actually on a real graph, you might be able to tell and then just pick those 2 points without going through all of this stuff. Distance formula. Our x's are 0 and -3, so 0 plus 3 squared. Plus our y's are 6 and 3, so 6 minus 3 squared. Somebody plug all that into their calculator and see what you get. That 9, 18, square root of 18 is what, about 4 point something? 4.2? How far is it from here to there then? 4.2. How far is it from here to there? How about from here to there? 4.2. All those distances should all be the same.
On those, I get confused. I mean, make the line.
Wait.
Like, where do you decide?
You pick a point. So we want to pick a point. I picked this point this time because it was easy, 0, 3. You pick a point that's on one of the 2 lines. It doesn't matter what point you pick. Alright? So you pick, I just happened to pick that point because it was a pretty easy point. And then we got to figure out, okay, if we draw a perpendicular up to here, what point's it going to come up here and hit? But where you start at, that's completely up to you. You probably don't want to pick this point right here because it's going to be some decimal and that makes our problem harder. We want to pick some point that we know the coordinates for. Does that make sense?
Mr. Everson.
Yep.
I got, I did the square root.
Yeah.
And I got 12, and then I did the square root of 12, and I got 3.4. I put it all fit in there.
So what's the y-intercept?
There is none.
So what is it?
Is it just straight up and down?
Y-intercept is 0.
Oh.
If there's not something shown out there, then just put plus 0. On the worksheet, don't take off until I get all this stuff done. On the worksheet, do at least 40. I probably better make it more than that, shouldn't I? Because some of them are that easy. Do at least 45. At least 45. The second part of your assignment. Take this home, get it signed, unless your parents. Yeah, that's because I do it.
Oh, we're having names.
Unless your parents tell you that they've already sent me back an email about it. So second part of your assignment, bring this back. What is today? Tuesday? Bring it back on Thursday.
For real, now I need a shit. Fine, you take it up there and take it.
We good to go?
Yeah, if you got the paper, take off. Take it anyway. Sorry guys, bring it on.
It's not just like you said, John.
I did that. Because
One piece of paper isn't gonna hurt.
it did. Yeah, if you need graph paper, some over here. Do this. When you close that parentheses right there, it stops the square root. It just got square root of 3. And 6 minus 3 is 3. Square root of 9. 3 plus 9 is 12. So what you'll have to do, is you want to do that, take the second square root. See if I can. You still looking at it? Yeah, it's another piece.
I'm gonna do it right after school.
Well,
They close at 10.
that square root, a little small, is actually around that whole thing, because we put a parenthesis here.
What'd they say? He said anything, Willie just took it. He said,
Apparently you got it switched already, you found out how to switch it
I told
from
Steph,
radical
she was
form
like,
to the
no,
other form, right?
Yeah.
I told her they ain't putting everything.
Yeah,
no.
Huh?
Tell her to put it, I just tell her to. She did fine. She's like, I don't care. I told her I was taking it.
You turned it into me because I put it in, so. But your name won't put on my name.
So pretty good. I am. Don't have that suicide prevention.
I just think
If you look back at it, it might get it on there. It's not my name.
No, I just feel like
I think sophomores tomorrow.
That is private. But if you look on Google, at your grades, and see what you were missing and stuff.
What?
So good. I didn't say it like that. Say you killed What? Say you killed teammate. Yeah, dude.